Yes, friend. Now we are going on again. We'll continue to our topic. Progress of work. So let's start here. Let's say images are all around us, all around us. From application icons to from applications application application icons to animated GIFs. Yep, photos. Okay. Mm, let's say images files can take up a lot. Images file files image files. Sorry, image files can take up a lot of space. Can take up mm, lot of lots of space, right? Mm-hmm. Space. So computers employ. So computers employ a range of algorithms, of algorithms. Let's take this one little left. What do you think? Maybe upside we can check. Yeah, it is good here. Let's take little here. And maybe it can be good then. Right, something like that. Let's put there. And really just take this one little left to this place of algorithm. Mm, algorithm algorithms to compress image files. So we know we have pixels. We have to convert pixels to bits. So it is bitmap operation. Okay, bit mapping. Let's come down for the simplest of images. For the simplest of for the simplest of images. So images, computers can use a compression. Computers 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 can use a compression algorithm. Call it. Let's take down. Love it. Call it run length encoding. Yes. This is important for icons and for fax, and some kind of technology like that. Now things are changed in our world. Everything's come in the details with details, and really, so we have to improve our skills to convert all of things in the digital system from analog. Let's speak about that. This one is RLA. It's run length encoding. And really I have to tag this running encoding in the different color because so just I'll notice you here. Okay, I'll notice you. This is important place. Let's come down now. Other topic will be here. Bit maps. Let's tag in which color, this color. This is get. Okay, After that, let's do this one like that. Let's go down. Mm, let's put it there, and just I want to come down here, right? Let's come down and write here before, right here, scientific article. Before we explore image compression, let's see how we can represent. Let's see how we can represent an image in an an image in binary. Yeah, without any compression. Without any compression. Yes. So here here's simple image, 16 by 16 heart icon. Okay, that's how we can look at it. Let's say something like that. If I can, mm, how we can check it now? Let's go to files. Mm, okay, let's go to downloads. Right. The first one is this one. Okay, this is the 16 by 16 icon. Okay, let's close this place. So I mean, this one is 16 by 16. Okay, if you want, just do it like that. Have you seen the contrast change? Let's do it 1500. This is now a little different than before. So anyway, let's come like 200%. Yeah, it is good now. Now if you check here, uh, it is little bit looking like with the you can think like with the precision, right? Because I think 3 minutes ago, if you saw, this is not real. Uh, they're looking good. Okay, this is like with the contrast. I mean, opposite side. So there is no precision too much about it. Anyway, let's come back. I mean, make it 100. Okay, this is 16 by 16 icon. What I can do, maybe I can take this one here. Can I do? Say okay, if possible. No, I think it's not possible. Mm, let's try it again. File format not recognized or file to convert. Okay, thank you. Anyway, now I will say this is the image file here. Let's try to open it in different in new page. Okay, this is here. You can think like that. It is there. Okay. Yeah. Now let's go from here. And now we will see this image. This is 16 by 16 image. Okay. So what I'm saying here, now just think like if I do, but anyway, it will not do anything now. Just say if you go to a little near to this icon, so you will see some details there. Okay, there's some point like It can be 0 0, then red can be 1. Anyway, we will speak about details for now. Just keep going on. Now what I want to do, we will write, of course, we'll write lots of things together. Don't worry about that for this idea. Let's join me for this point. Yes, tag pencil again. Yup. And say, let's zoom in an overlay, overlay, grid, grid on, grid on top, 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 so that it is easy to see. That, so that it's easy to see exactly, exactly which pixels which pixels are red and red and which uh, pixels pixels uh, syntax error, it's really going crazy, are red and which pixels are white. I told you, really, guys. So now if you go in details, you will see here, uh, let's come little up. Okay, our point now here, look, white. Let's go a little bit more in detail. Each pixel you can see now here. Let's do it in, yes, look, this is white, first pixel, and let's anyway, I don't want to do it. First pixel is white, second pixel white, third pixel white, four red. So you can say 0 0 0 1 1 0 0. You can go like that because bitmap operation, bitmap process is really like that. Okay, so we will check with all kind of experiments through to check the progress here. Okay, come back. Right. Let's go a little right, like that. Yes, and then we said white. Now we will look other image. So I showed you, but I want to do again this. Let's close this one. Yeah, here the second one is that. Let's we can copy it, right? Maybe we can do something like that. Let's take this one here if possible. Right, it can be here. Okay, this one is like that. So we just tag zoom in this icon. So if you go near it, like 800 zoom or 1000 zoom, we will see this icon like that. Okay, this is the point, so we have to understand. So anyway, now in this point, I told you we have white, 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 red, red, white, white, white. So now we have to encode them. This is the uh, run length encoding, okay, algorithm. I mean, you're just converting pixels to bits. Okay, this is important point. You will do together. Don't worry about that. Okay, let's come down. Let's go a little up. Oh, okay, I don't want to lose new line point. I think here. Let's say here. Maybe I can do something like that. Let's go down. Yeah, I can do something like that. It's okay. Let's say the heart icon is made up of the heart icon of is made up of only is made up of only two colors. Right. Two colors. Because first one is red and white. So a computer could represent it could Peter computer could could represent could represent it in binary by mapping red pixels red r- pixels red pixels to 1 and white pixels to 0. This is good. Now we will represent with the what? With the integer, maybe you can think like that. But anyway, just don't worry. This is bit, okay? So mm, let's say this is called bitmap. Let's take the point here. This is important because let's take in a important like that. Let's make it black again. Words. Okay, this is good. Let's close there and go back. Go from here. Oh, it's again same. Let's take the right. Let's say something like that. No, what's happening here? Let's do something like that, and we will start here to say, since it is it is mapping pixels to bits. So before, so it's just we're representing with the bits, okay, not integer numbers. Just follow me, okay, in this point. So let's take this others information from here in the black. Okay, and then let's say using using this method, this method, the hard icon would be represented like would be represented like like would be represented like so. Now we will do one amazing things. Let's join me here. Okay. What I want to do, with you, just okay, come here, type this one, start from this place. Let's say 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0. Anyway, in this point, I will open music. Um, you can listen music when I finish it, and we can go on. Anyway, now it's finished. Have you seen here? So, have you seen here some heart icon? Just look in details. So it is little bit um, composite. I mean, it is next to next too much for that. Maybe you can't understand, but if you look in details, you will see here like that. So maybe I can draw it. Let's tag and this pencil. So in this point, like that, let's think it's coming like that and going again. Okay, anyway, something like that. So something like that. It is. So just think like that. Okay. This is heart icon. This is the important point we got here. We're representing white colors with the, I mean, background of frame. I mean, background of framework. So we are just representing in the framework white colors with the zero and red color with the one, and it is a solution like heart. I will give you too much example for understand this concept. Okay, this is really like that. This is not different than this. Let's come down and what I want to do, let's come here. Okay, in this point, let's write. Imagine that. Imagine that you had to read the bits. You had to read. You had to read the bits above what? The bits above out to to someone who was copying, who was copying, who was copying them down and down. After a while, after a while, you may say things. You may say things. Still, my music open anyway. I have to close. Things like five zeros. So I mean this one instead instead of zero 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 zero. So this is the key how we are compressing our pixels. Okay, just think five times the zero is just recurring. I mean zero 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 like this place. You can think this place. Okay, this, look at that. One, two, three, four, five, six, seven. We have seven zero. Like 70. Just we have to say seven for represent zero, not 0000, because it will take lots of store in your computer. It will take, so you can compress them to show it in the some bits. I mean with the small bits, because if you use like that 000 all the time, if you write 000, it will fool your store. It will take lots of bits to represent something. Then the computer have lots of space. Now in new technology we have new computers, but really we can compress them with the run length encoding. This is simple. Okay, let's say 000 and say, well, the computer can do that too. The computer can do that too. Yes. So now our other topic will be about that. Let's start about it. This one will be RLE, running encoding, compression, compression, algorithm, algorithm. Let's tag in the blue because our other topic is that. Yes, this one is good. Let's come come on down here. Right. Start to write. In run length run length encoding. Yes. The computer replace the computer mm, replace replaces each row with numbers. Let's say how many that say how many let's say many how many consecutive 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 I think, right? Consecutive pixels are the pixels are the consecutive pixels are the same color. So always starting the with the color of with the number of with the number of white pixels. So it is always starting with the white colors, okay? If there is something started with the red colors or any different color, but just there is will be two option, okay? uh, just think the I'm speaking too much about icons because this important point here, the icons, because this is the point here. Anyway, the always starting with the white pixels, okay? Just if there is something starting with the red, just you have to put first place zero for the white, then you putting your other color numbers. I mean, how many color pixels I have there, just you can write it. Let's say for example for example the first row contains the first row contains the first row contains three white pixels, two red pixels, two red pixels, five white pixels, five mm, five white pixels, and two red pixels, then four white pixels, then four white pixels. So what I'm saying here, I'm speaking about this point. Let's look together. This is here. This one is we sang white, three white color. Then we have two red. Then again we have five white colors. Again we sang zero, white. Okay. Then we have red, and we have white. So what I'm saying here, let's open it again in this point. Yeah, close this place. Yeah. Let's look at here. I mean, I'm speaking about this place. Three white color. We sang 000. We're representing white colors with the zero. I mean, white pixels. Then we sang 1. But this is long way to do things. Okay, after all of them, we will say just 3, 2, 5, and 2 and 4, something like that. Anyway, let's speak about here. This is the key point, and we have here 5 and 2 and 4 is going all the time like that. It can stay here. Now I will show you how we can represent it. This would, wow, let's come right, would be would be represented presented as follows. Follows. Yes. Then let's come here. Uh, really, this is just like 3 white colors, 2 red colors, 5 white colors, 2 red colors, and 4 white colors. Yeah, we compressed. This is easy. Okay, now let's do detail. Let's say here the fourth row, fourth row is interesting because it starts with a red. It's starts with a red pixel. Run length encodings. Run length encoding start the, with the number of white pixels. So this is how. So this is how it it be represented. Have you think about that? Represented. Yeah, the solution for that what, let's come here. Yeah, maybe here. Let's open this one again. The 4 is here. This point. I mean, have you seen that? 1 rows, first row, second row, third row, and fourth row. We have here, if you check 16 by 16, this is 15, end of this place. 15, this is 16. The 16 is white, representing with the 0. Anyway, we have 15 red. And we really, this is starting with the red. And this is not starting with the white. But in running and coding, all the time is starting with the white because we have to represent like that. What we have to do here, the important point here, for the displays, what we have to say, 0. If there is no white, so if starting with the red, we just saying for 0, this is, so for the white, we're saying this is 0. It's starting with the 0. Let's do it with me. Let's say 0. And then what we have? We have 15 red, right? 1, 2, 3, 4, 5, and 15. End of this one is 16. So 15 we have red. Let's say 15. And then what we have? We have only one white. End of this place. Where is it? Right here. This is white. It's starting with the white. White is 0 because there is no white. It's 0. And we have 15 red. And last one, our again white, we're representing with the what? 1, because this is 1, only 1 there. So this is that. Let's say check your, I can take little down. Yes, let's come down. Let's say, check your understanding. Let's take this one in this color. Okay, and then really just come here and let's say here, here, the second row of the bitmap, the bitmap for the heart icon, for the heart icon. Speaking about second row will be like what, like that. Let's come open here. Yeah, let's take this one in here for the reference. We can tag reference here. Yeah, it can stay there. Let's click this point again. Yeah, the second row, if you check, it is starting with the so 0 0, and we have 1 1 1 1 for red, and 3 0 again, and we have 1 1 1 1 for 1, and again 3 0. Okay, if you want, you can check. It is possible for you too. So let's let's what's happening here. Uh, mm, this is, yes, I think you got what I said here. I think you understood. Now we will say uh, would how would that row how would that row be represented in RLA, so round length encoding. Okay, we have options here: A, B, C, D, E. Okay, really, we don't need to open this image. Let's come here. Now look at here. We have 2 0. 2 0 can represent with the 2. But anyway, just write first the options. 4, 3, the 4, the 3, 3. The other one will be just like 0 2 5 3, 0 2 5 3, 5 3. Other one will be, if you can solve with your eyes, this is amazing. So if you can make process with your eyes, really that's possible for progress of work. This one is 2 4, because this is cognitive, right? 4 3 4 3. This is that. Let's come other one right here. 0 2 5 4 5 3. Last one is will be 0 2 5 3 5 and 3. Okay, this is starting with 2 0, so it is 2. Then 4 1 half, so 4, we have 4 1, 4 red, I mean, this is 4, this is 2 2 2, that's wrong. Then okay, only this option, 3 and 3, and 4 1, I mean 4 red, and this is representing 4 red, and we have 3 white, and 3 white is representing with the compress like that. So we can say, so let's tag green. Oh, what happened? Tag bag. That's only tag this pencil and okay, this is the uh, true. This one is wrong, 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 wrong. So now we know how to represent it, right? I hope you enjoy with me, right? This is the important point, I mean, for progress of our work. So, uh, and then we will speak about what, let's say RLA, run length encoding compression. This is also important, believe me, the compression. So let's tag this one into blue color, already there. Our other topic is that, let's say here, when when a computer uses run length encoding, when computers using using uses sorry run length encoding, it should be able to perfectly mm, perfectly recreate the image icon, recreate recreate the image from icon, from recreate image it's wrong, image from the compressed representation, from the uh, compressed representation. And so should we if so should we what is that so should we from the compressor representation, so should we let's say something like that. Anyway, let's say if we follow the computer strategy, follow the computer's strategy strategies computers the third strategy, let's say, let's take this one little left. Yeah, so what we are saying here, just think, it should be able to perfectly recreate the image. Just think all the things we are compressing, like that, the composition happening there. And when we open this K again, it have to be image. When we open this compressing, so when we decode this compressing, all the things will be turned again like icon. It have to represent red, white with some way. Okay, let's try it. Let's try it. Here is a representation of a block and of a block and black, sorry, not block, black and white icon, using white icon using RLA, running encoding. So what I'm saying here, let's come down. So I'm saying here, the things here important. Let's tag close this place because yeah, let's tag this pencil again. So text place. Okay, I'm saying black and white icon representation. Now I will show you what we did with the heart, how we compressed it. We have 4, we have 9, 3, and we have 4, we have 7, we have 2, we have 1, and we have 2, we have 4, we have 7, we have 2, 1, and 2, again same, and we have 4, 9, no, yeah, 4, 9, and 3, and again we have 4, 7, and 5. Again we have 4, 7. Maybe you will confused in this point. You will say, hey, how we can represent this 2, how we can compress this 2 because it's same, right? But don't worry about that, really. So we will solve together. 5, 5, 6, 5, 5, 6, and we have 0. I showed you that example. It's starting with the red, but we're just representing with the what? With the white, like we saying for white it is 0, 1, and last we have 1, 13, 2. Okay, now what I'm saying here, do you want to try this one as with some way? It can, you can think like we have 2 colors, 0 and no, white and black. The first one will be white, 4 white, 9 black, 3 white, and 4 white, 7 black, 2 white, 1 black, 2 white, like that. It will go all the way. Let's look what is that. But before look that, let's write all the time. The first row has 4. The first row has 4 white pixels. Pixels, or pixels is pixels, and pixels. Then 9 black pixels. Then 3 white pixels. That looks like what? That looks like what? What do you think? Looks that no, that looks like, yeah. What I want to try, just think. Let's take pencil. Okay, I will try something with you. Let's say we have 2 color, red. No, what happened? Close this one, this place. Okay, let's take again. And let's say we have 2 color. Okay, the first one is red. No, maybe red, maybe white. Okay, anyway, this can be white. Let's say this one is white. Okay, let's bring here our thing. It can be which color? Let's say this can be uh, let's say purple. Okay, now what I want to show you, we will plot together this icon. We have 4 what? We have 4 white. Let's tag here uh, 4 white rectangle in this place. Let's draw it. 4 white, right? 1, 2, 3, 4. 2, and let's take this place 3, and this place it's 4. We have 4 white and 9 black. Let's tag again this one here, click it, then come here. uh, no, maybe we can duplicate it, and let's come right. No, what happened? Let's duplicate it and let's come right. This one will be black, black. Okay, then what we have here? 2. How many? 9. 2, 3, 4, 5, 6, 7, 8, 9. Yeah, and then we have 3 white. 1. Let's take it there. 2. No, come here. 3. This is good. And then what we have? We have 4 white again. So we have same here. Things the same. Let's take down to this place. And then we have 7 black in this point. Okay, we have 9 here. Let's take 2 less. Okay. Yep. We take 7, and we have 2 white. Let's take 2 white from this place to there. 2 white, and we have again 1 black, right? 1 black to this place, and we have 2 white. Yes, yes. Let's tag it there. Good. And we have 4 white again. So 4 white all the time will be like that. Let's tag this down 2 times. Okay, 2, 4, 6. Yeah, take 2 more. Okay, 2, 4, 6. 6 times it's coming there with the 4. Now we are 1, 2, and this point. We are in this point. This will be again 7, like that, like upside. Let's duplicate it and come down to this place. And the other one will be 9, like that. Like what? Like that. It will be 9. Let's tag it. Let's come down. 9. It will be 9. And what we have here? 7, 7, and 9. And we have 7, 7. Again, 2, 7. Like we can tag this point for that. Like that. And let's tag more down. Oh, I think we forget here to tag this point little left. Let's tag left. Yep. And tag this up to right. 7, 7. I will do this place, but before do it, just let's do other ones. Anyway, this one is okay. The second is okay. The third is we have 2 white here, 2 white, 1 black. So I mean 2 white and black. This one here, it will be same. Let's come down with it, right? If I'm true, and we have again 2 white. Let's take this 2 white there. I don't know still what it is. We will solve together. This 2 white is there. Let's look at here. We have 9 and we need 3 white. Let's take 3 white. 3 white is will be here. Okay. It's also okay. Here we have 5 white. 5 white. 2 times. Let's duplicate it. 5. And let's duplicate it again. And let's tag these 2 white here. Duplicate it. Let's take them down. Okay. White, white. I think this point is true. We have 3, 4, 9. Say 1, 2, 3. 1, 2, 3, and 4. Okay, this point is true, I think. Yeah, then we have, but here we have some problem, I think. This is 3, 1, 2. Okay, this point is true, I think. Then we have 5, 5, 2 white. 5, 5. Then let's try 5 white. This is 5. This is 4. Yeah. Let's do them 5. Tag one more. So I mean duplicate it to right. Let's take little right to the this. Okay. And again 5 black. This one is how many? 5. This is okay. Bring it to this place. Let's go a little left. It's okay. 5 and we have 6 white again. And take this. Duplicate it. Let's go there. And let's put one more. Let's go a little right. Yeah. And then we have 0 white, so 0 already 0, and we have 15 black. Let's take this is 9, I think, right? 9, and let's take 6 more, maybe. Where is it? I'm not seeing it right here. And we have 1 white in this point. Let's take down. Okay, and then what we have? 1 white. Let's take 1 white here and 13 black. What we have here? How many black? It's 15, right? 15, then just take last 2. This is 13, I think. And we have 2 white. But here it's not good too much. Let's take it really little left, right. And let's take 2 white. 2 white. Yeah. What is that? It's finished. This is, let's, where is the frame? Frame is here. Let's do this red. Maybe white.